Hi, welcome back to the channel. So in this video, we are going to see the problems on the op-amp. The first problem is find the gain and output voltage for the given input voltages, right? So they have given you the input voltages, so you should find the gain and output voltage, right? So here, uh, from this example, we can understand that here I have a gain which is nothing but output by input, right? So they have not mentioned here what type of amplifier. So assume that now if we are mentioning like non-inverting amplifier, assume that in the problem it is mentioned like non-inverting amplifier at that time. So my equation of gain is going to be like this, right? So now here I want to calculate what is A, right? A is equals to what? 1 plus RF. So here it is gain is like this, okay? So if I want to write this gain 1 plus RF by R. What is RF and R which is given? So in this case there it is given as 1. So it is 1 plus RF value is 10 kilo and R1 is 1 kilo. K will get cancelled. 10 plus 1 is 11. So what is the value of A? It is 11, right? Now, and also you should find what is the output voltage. So how to calculate output voltage? Same expression, output is equals to what it is? Gain into input. What is gain? 11. What is the input? Input is given. What is that? 0.5 volts. Right? 0.5 means half. So what is 11 by half? Sorry, 11 by 2. 11 by 2 is 5.5. Gain is 5.5. Sorry, output voltage is 5.5 volts. This is the answer, right? So a very simple question. And also they have given one more, that is minus 3 volts. For minus 3 volts also you should do the same here. So how to do the minus 3 volts? So gain is 11, but for minus 3 volts how we can write? A into V in. What is A? A is 11. What is in? V in 3. So it is minus 33. Output is minus 33 volts because input is minus 3, gain is 11. What is 11 into 3? Minus 33. Gain is 11 and it is 0.5, so you will be getting 5.5 output voltage, right? So now we'll see the second problem. Second problem is a little bit different compared to the previous. Now with respect to this, they are asking you to find out output voltage. How to find the output voltage for this? Now what type of amplifier it is? Input is given to plus. Plus means it is what type of amplifier? It is non-inverting amplifier. If it is a non-inverting amplifier, I should use the formula for non-inverting amplifier. What it is? 1 plus RF divided by R1 multiplied by V in. Right? Now, you should observe this V in very carefully. Here, V in is not connected to plus terminal, but instead what it is connected? B voltage. Right? So this V in should be replaced by the voltage, and that voltage is called as VB. VB is a voltage which is given as a non-inverting terminal, right? So now we should calculate what is VB first, right? So how to calculate VB? VB is at this means it is 1K divided by 1K plus 1K, that is 2K, right? So I will write it as 1K plus 1K multiplied by input voltage. What is the input voltage? Input voltage is 10, right? So it is what? 1 divided by 2 multiplied by 10. 2 ones are 2 5s are. So what is VB? VB is 5 volts. So this value we come to know that it is 5 volts. Now just substitute here 5 volts so that V output is equals to 1 plus RF. RF is given 50. R1 is given 10K. And the entire thing multiplied by what? Entire thing is multiplied by VB. VB is 5. KK, 10 ones are 10 5s are. So it is 1 plus 5 6, 6 5s are 30. So you will get as 30 volts. What is the output voltage you got? 30 volts for this. So that is what only this one voltage you should understand that it is the input to the system, not this is the input. So in the exam you may get confused that 10 volts you will put here V in and you will substitute. No, it is not. It is wrong at that time. At that time 6 into 10 is 60 volts you will get. No, it is 30 volts. So like this, it may be the MCQ questions or it may be a descriptives in the competitive examinations with respect to the op-amp. They will appear like this, right? So this is the basic concepts. These are the basic concepts in what is that? Basic electronics or introduction to electronics classes, right? So these are the problems. Now we will see one scaling problem, uh, which is about the inverting summer. So that is our inverting adder or the inverting summer. How the problem will look like? Most time the problem is going to be repetitive. So that problem we will see. So here the question is, you should design. What you should design? You should design the adder, right? To obtain output expression. To obtain output expression is given. V output is equals to minus of zero point 0.1 V1 plus 0.5 V2 plus 20 V3. So this is a question, right? So where V1 and V2 are, they have given that these three are inputs. So this is the problem. You should design the adder now. They have given the output expression. Now you should construct that adder circuit. So by looking at this expression, it is minus. So minus is stand for what type of adder? Inverting adder. Assume that it is plus. At that time, you should treat that it is non-inverting adder. Now it is inverting adder. So what is the output expression for the inverting adder? We know minus of Rf divided by R1 multiplied by V1, Rf divided by R2 multiplied by V2, Rf divided by R3 multiplied by V3 if it is 3 inputs, right? So now compare this equation number 1 with equation number 2. If I compare, what I will get? Rf by R1 is equals to 0.1, Rf by R2 is equals to 0.5, Rf by R3 is equals to 20, right? So now Rf is there in all the cases. So I will consider Rf as 1 kilo ohm. I will assume, right? So if Rf is 1 kilo ohm here, so 1 kilo ohm divided by R1 into 0.1. So I will take R1 as 1k divided by 0.1. So I will not find out the value here. So what is the value which I will get? That is, I will just keep this. So here R2 is equals to Rf 1k divided by 0.5. Similarly R3 is what you will get? 1k divided by 20, right? So I have the answer for this. So here you can, instead of taking 1k, so I have the answer for this. If I take 10k, okay, so I will write here what I will get if it is 10k. If it is 10k, R1 you will get as 100k. So if it is 10k, R2 you will get it as 20k, and R3 you will get it as 500. When the assumption is 10k, whatever you can assume here, this assumption part you can assume whatever it is. So I got R1, I got R2, I got R3, right? So once I have this, now I can able to design the diagram. How to design the diagram? How to design the diagram, right? V1 resistance, V2 resistance, V3 resistance. All three are connected to inverting terminal. Non-inverting terminal is grounded, right? So what is the feedback resistance? It is Rf. What is the value of this? We know R1 is 100k, R2 is 20k, and it is 500. Rf is, we have chosen that it is 10 kilo ohm. It is the output. So here, this is what the design. This is what the design of the given problem which is given, right? So that is a. So assume that the same problem. So the same problem can be asked in a different type. Now look at this. Assume that they have given like this. Two, they have given something like 0.1 V1, 0.5 V2, 0.5 V3. So they are given like this, where V1, V2, V3 are inputs. So now you can observe here it is plus, right? So what is the type of adder? Non-inverting adder. So how we are going to get plus? Can I write like this? Minus of this, again minus of minus. We can take it as minus of minus, so that it becomes plus. So what is the meaning of that? First you can do the inverting adder, right? So first you can write the inverting adder, right? then whatever the result you got, after that again minus is there. So inverting amplifier you can take. So that is the meaning of that. Okay. If it is plus, if it is minus, no issues, only this part. If it is again plus is there, you can minus and minus. One minus is for this and this minus is for inverting amplifier. So here 2 will come into the picture, inverting adder, and it is inverting amplifier. Okay. So this is a problem how we should solve it. So if you have any doubts, you can put it in the comment section so that we can help. Thank you.